We're going to discuss the importance of ecosystems within the IoT marketplace. We've got a wonderful set of panelists with us from Telefonica, T-Mobile, Qualcomm, Microsoft, and KDDI. Unfortunately, our friend from Legato wasn't able to make it. He had a little stomach flu, so hopefully we can cover for him. Well, I'll let each one of our panelists introduce themselves when they get to their presentation. The structure is pretty simple. We're going to have each one of the panelists talk about their perspectives and point of view on the IoT ecosystem. They'll take about 10 minutes or so, and then we'll move on to the next one. Hopefully, if we have some time, we'll try to take a couple of questions, but I highly doubt we'll have any time left. So first, let me set this up. Today, enterprises and industrial companies are looking for end-to-end solutions. They're looking for solutions that are not just only the hardware, but the software, but it includes all the elements between the network, the semiconductor, the chipset. They want one single turnkey solution because the market is highly fragmented and complex. They want essentially a pre-integrated solution. To make that all happen, you need a robust ecosystem of partnerships and channels. And again, we'll hear that from our esteemed panelists. At the same time, the private network, there's a proliferation of private networks and other network technologies. We've heard of Sigfox, LoRa, lots of LPWAN type technologies, but also increasingly private LTE. We're beginning to see some of that also take form within the industrial enterprise sector. But beyond connectivity, I think telecoms can offer a lot more. I think they can provide some of their expertise in OSS and BSS, and especially the back office. For many, many years, they've been managing and operating networks that are highly complex. And at the end, industrial companies are going to become network-based companies, similarly to telecom or a logistics company like UPS or FedEx or an airline. They're all network-based companies. And who better than the telecom sector can help them get there? So with that, I'm going to ask Andres from Telefonica to present his perspective. Thanks, sir.
Okay, first of all, thank you for this opportunity to share with all of you the view of Telefonica regarding with this exciting world of IoT. Internally, we're talking about the infinity of things instead of Internet of Things. And this is a conceptual view that we have regarding with the step that is necessary to follow to reach this view of the IoT. We need to, let's say, avoid to any of this step because it's important to let's say, create this little, let's say, phase until we are complete the products or the solution around the IoT. The first thing is collect the information because it's the real world. We need to obtain the information from different sources, different situations. We need to connect this information and transport to the cloud, to the other system to be processed. That is the third layer, where is processing many, a huge amount of information coming from different sources in a heterogeneous way, etc., etc. But the real phase, the important phase, is the analysis. Is where IoT makes powerful or became a real solution because it's when I take decisions or, let's say, execute orders in the real world. Okay. Let me pass to the business view. Only for put people in the same page. When I'm talking about the IoT solution, there are 13 components that is necessary to, let's say, taking care. The first thing is the connected things. There are many of them. Wearables, chips, cars, there are many of them with not only one sensor, plenty of sensors. We need to connect these things to be, let's say, to become smarter because in other case there are things that is stacking, they are storing information but it's not processing that. We need the IoT platform that is first connect the information independent of the technology that you use, and the second transport the data and manage the data from the things to the cloud or the systems. Other important point, this is the customer IT, because doesn't forget that there exists a legacy systems that is necessary to interact with a new service, with a new concept of IoT. We need to simplify the way to do that through APIs or through other kind of, let's say, mechanisms to simplify the way to integrate the existing with the new world. Obviously appears the IoT solution. That is the real, let's say, dashboard on apps that moving all this information and take actions over the IoT analytics, that is data coming from these sensors and processing it in the right way to extract the right decision over the business process. Okay? In 13 case appears the end user, for example, with the consumer IoT, car connected, etc., etc. I mean, it's important to close the loop. And at the end, there are an important part that you usually forget, but is critical, that is the IoT security, okay? The IoT security is necessary to be embedded in any of the components of the solution, because the only way to guarantee security in the IoT concept is if you are cover the whole view. This is my colleague calling that the fear slide, okay? Let me put the focus in the LTE. I think something anticipate a little bit how powerful is LTE, but for me it's critical to explain that it's the first time that 5G or the pre-5G technologies is developing for Internet of Things. As you see in the upper line of the evolution, this is the traditional evolution that maybe you know for the consumer side. All things related with your mobiles, smartphone, etc., etc. But there are other two lines of evolution that is critical for us. The first one is the bottom up, that is the start of the LPWA, all things related with LTE category M or narrowband IoT, means names that you know. But appears other third one that appears maybe in years later, 2 or 3 years later, that is the ultra reliable solution, B2X, other kind of solution. There are acronyms that is maybe you in the next year you are starting to know about that. The important thing with this slide is we have different flavors, but it's converged under the 5G. And the question here is, we are able to open business with LPWA, with IoT today. We are not waiting for the future because 5G is coming, is here. But what's happened with this kind of technologies? Every new technologies make a jump, okay? I try to use an example of the different players that is part of the ecosystem of IoT and the different speed that these people has, okay? Imagine that what's happening in 2G, 3G, 4G, or people know about that. There are plenty of partners, there are plenty of providers, plenty of vendors, and plenty of, let's say, telcos that are using this technology. But what's happening with the new ones? The problem is the speed. Every has different speed. Standardization is on speeds, vendor has other speeds, telcos has other speeds. At the end, the more important one, the problem that we have today is the business development, the business solution. We are not speed, or we are not faster enough to guarantee that really the business is changed dramatically. We don't consider LPWA, for example, a mature market. It's starting, okay, we have a good proposition, but today we need to move and reach this kind of, let's say, traditional business like a 2G, 3G, 4G mature, because today, in 2 or 3 years, starting the 5G. We need to move today to guarantee that the 5G comes. For that, we need to, let's say, move with this kind of, let's say, phase. We consider, for example, the hybrid solution and a very real alternative to working with this kind of migration, because we take 13 time until we deploy the networks, etc., etc. And the hybrid solution, from the point of view of the chipset, or from the point of view of the IoT platform that is able to manage 2 or 3 technologies at the same time, is critical. And obviously the future-proof design, taking care about the hardware side to avoid make change in the future and minimize the impact of the new technologies launch. This is from the perspective of business, okay? They are, for me, the issues that we have today to solve for really accelerate the deployment of the IoT ecosystem. Security, delivery on time, we are talking about digital service and it's necessary to launch in a very short time to market. Globalization, we don't, let's say, design solution only for your specific local site, we need to think it in a global site. The full integration, because usually we design something for my slot and that's all, we need to think in the whole view. Obviously standardization and certification, because we are moving millions of things around us and around the world, means we need to guarantee that this kind of, let's say, solution working for any networks, any vendors, any technology. And one important point for me is the technical availability versus commercial availability. One thing is in a lab, the things working properly. Another thing is we are able to launch massively the commercialization of this product. Okay, taking care with that because it's one of the things that is, let's say, create overselling of this kind of technologies. And the last point for me, and I am provider, but it's critical: price, price, and price. If we are not able to aggregate or reduce the real price of the new technologies, it's quite difficult to accelerate the deployment of this kind of technologies. Let me put a little example about how important is the big data and artificial intelligence for us, like a part of the solution. I use a case for Industrial 4.0, specifically for the logistic case, thinking that today we are able to extract a lot of information about many players, many components of the supply chain. For tracking last mile, we are able to tracking the assets, we are able to create the mobile tracking for the trucks, etc., etc. But it's not enough. It's something that maybe for a dashboard is good, but it's not moving. The real important thing is the data-driven decision business. What means this kind of definition? Is when we process all this information coming from the sensors and integrate it in the final solution. This is for me key. We have, for example, in Telefonica, we're creating different artificial intelligence solution for consumer. We are starting to working in the enterprise side because we consider that is the only way to extract the real powerful to the, let's say, Industrial 4.0 for the Internet of Things solutions. Okay. And now, let me introduce the things. The things for us is our concept for accelerated ecosystem. It's more than an open lab, it's an ecosystem, it's a business ecosystem. It's part of our idea of how it's possible to create a point of, let's say, of aggregation of knowledge about the Internet of Things and support from our side, or little startup, or big multinational, or customer that need to test end-to-end solution. The things is divided in different cycles. The first one is a technology lab where you tested many things, but the duration, environment, technologies, etc., like a technical lab with the support of different partners that are working with us. Other circle is the partners center where it's possible to integrate this solution in an end-to-end solution, an end-to-end IoT solution to check that it is working properly. And the last one is the new ecosystem center. When a product is integrated and is tested, we use the channel of Telefonica and his partner to launch this product to the market. This is an example of how we believe that it's possible to accelerate the ecosystem. This is, we don't have a lot of time, but this is the view of Telefonica. There are more points of let's say, of acceleration of the ecosystem. One of them is the concept of the IoT framework. We don't have time to explain in detail, but if you are interested, I explain later on. But the important thing is the future. Remember that we're talking about 5G. For me, it's a critical thing that we are able to work in today, but the future comes as soon as we deploy these new networks. And something like a IoT car environment, all things that is autonomous car, car connected, etc., the smart cities. Today we have cities connected, but any kind of village or any kind of city is possible to be connected through these kind of technologies. Consumer IoT, there is other things that is changed dramatically the rules of the game changer, because it's affected all of us, not only the companies. And the industrial IoT, that is, like I anticipated in the previous slide, through the LTE enterprise or private networks, etc., there are many things that is possible to do. And for my side, remember that this is a question of ecosystem. It's necessary to working together, and we need to move faster because it's a huge opportunity, and we need to capture this opportunity for all of us. Okay, thank you.
Awesome. Thank you. All right, we have Kari from T-Mobile come in and give his perspective. There you go, Kari. Thank you. Thank you.
All right. Good afternoon, everyone. So my name is Kari, and I'm with T-Mobile US, responsible for technology development. Great pleasure to be here today and talk a little bit about our views about IoT and the way forward. Before I get there, I think that most of you, or many of you, don't really know who we are as a company, so let me spend a minute first explaining what T-Mobile US is all about. In the US, operators call themselves carriers. I don't know why, that's just the way it is. We call ourselves the Un-carrier. And I do know why that is, so let me explain. The reason why we do it is that we want to change our industry for good and for better. We are constantly and consistently listening to our customers to understand what their pain points are, and then fixing them so that they have a better experience and can enjoy the service to the fullest. To give you some examples of things that we've done, for example, we got rid of contracts altogether. We have unlimited data plans for everyone. We provide access to video and music to our customers for free. We thank our customers constantly and all the time. Every Tuesday, we call them T-Mobile Tuesdays. We give them stuff for free, whether that's a T-Mobile branded gear or maybe free movie tickets or discounts of all sorts, just to show our appreciation to them. And we even pay their Netflix bills if they so want, just to maximize that they can enjoy video to the fullest. And we do all those things because we value our customers and we want to make their life extremely easy. But that's not enough. You also have to have a kick-ass network, a really, really great network to provide best possible customer experience. For last 16 quarters, 4 years, we've had the fastest network in the US, and we're very proud of that fact. It's also the most advanced network. We take every single thing that technology allows us to deploy so that we can improve the experience of our customers. And thirdly, coverage is extremely important, so we've been relentlessly driving an improved coverage experience in our network, and today we cover more than 322 million Americans with our network. Just to put that into perspective, kind of geographically speaking, you could squeeze Spain into that coverage more than 11 times. So it's a pretty hefty geography that we cover with our network. And of course, when you listen to your customers, good things come out of that. And if you look at kind of the last graph on the bottom right-hand corner, in the last 5 years, we've more than doubled our customer base, and today, more than 73 million customers connect to our network every day and enjoy all those good things that I talked about. Majority of this growth, and obviously, has been in the consumer and kind of a smartphone segment. But we're not stopping there. We take IoT as an opportunity very seriously as well. So let me talk about that a little bit. When we started on this IoT journey, we kind of built this checklist of things that you have to have in place to be successful in the IoT space. The first one is obviously network. You have to have network that provides that ubiquitous coverage everywhere. First thing that I learned as a young RF engineer was no signal, no service. So if you don't have a network that provides the service everywhere, IoT is not going to work. So that's very important. You have to have plans in place that entice the IoT customers to adopt these technologies and make good use of them. Last month in January, we launched our narrowband IoT plan at $6 a year, not per month, per year, to connect an IoT device over narrowband IoT into our network. To manage those interactions between the devices and IoT applications and the network, you have to have the right platforms in place. You have to have connectivity hubs that allow or provide flexible and easy to use online tools for IoT connectivity. You have to have analytics so that you understand what's going on in the network, how do those IoT services and applications behave, and are they getting the service that they need. And then finally, you have to provide development tools so that you can let the innovation flourish in the IoT space, and people don't have to necessarily understand how telco networks work so that they can create different kind of applications in the IoT space. Speed to market is extremely important. Things move fast, so you have to have the ability to listen to your customer, and just like we do in the consumer domain, solve their problems for them. So you have to be agile, you have to be nimble, you have to provide a freedom of choice. We firmly believe in that. It's really, really hard to say or predefine that this is my IoT portfolio, take it or leave it. That's just not going to cut it. And if you want to be flexible, then you have to have that speed in mind all the time. And then finally, you have to have the right partnerships all the way from chipsets to modules to applications so that you can allow all these other things to happen. And if you can tick all these boxes, I think you have a pretty good starting point. We believe that there's a lot of potential in both the consumer IoT segment as well as in the industrial or enterprise IoT. But the approaches have to be a little different. For example, in the consumer segment, more often than not, branded products and solutions work really, really well. And you know who your customers are. For example, we have a product that we call Sync Up Drive. It's basically onboard diagnostics module that you can plug into your car, and with an application on your phone you get information on your car's health, your driving habits, and you can even provide Wi-Fi inside the car through that and the connectivity from our macro network. But in these other segments, more often than not, again, you don't want to necessarily constrain what those customers can deploy, and that's why you have to also have the ability to provide partner products. And there's a lot of innovation happening in this space, and it's important to understand what solutions exist so that you can work with your customers and give them the right solutions, either through your own channels or through a partner that you are aware of. But ultimately, connectivity is really everything, and it's kind of like, I would say, three things are in the heart of that. First, you have to have the network like I talked about. And no surprise, many of these IoT applications, they actually move around, so you have to support mobility as well. The next thing is that you have to have the right technology in place. Technology that's future-proof, technology that allows you to cost-effectively provide these services to your customer. And then thirdly, you have to be ready, and everything you do, you have to do that with 5G in mind. And if even a fraction of some of the forecasts materialize in terms of how many objects will connect through wireless networks in the future, you have to get ready for 5G very, very quickly. So we think that the right technology, obviously you have to have probably kind of a different flavors of IoT capabilities in your network, but most of these applications are really, they need wide area coverage, they have low bitrate needs, they don't necessarily or they need long battery life, and narrowband IoT is an excellent technology for that. We were the first in the US to launch and deploy narrowband IoT. We started last year. For example, I use here as an example the partnership that we have in place with City of Las Vegas, where we provided them and they've deployed different solutions from smart city lighting to environmental sensors to livability improvements. And narrowband IoT is something that we're deploying in our network today, and by summer or mid this year, we will have it nationwide everywhere. So the coverage that I talked about previously will have narrowband overlaid over that everywhere. And I think that's going to serve lion's share of IoT needs in the wireless space, but obviously other flavors of IoT or 3GPP family of IoT capabilities or device categories like Category M and Category 1 we already support today, those will become too, but most of these IoT devices I think really are a good fit with narrowband IoT capabilities. So why narrowband IoT? Because there are so many different IoT technologies and capabilities out there that what's the right, how do you choose the right technology? How do you make sure that the connectivity that you provide is based on technology that has that future-proofness in mind? And I think the first thing that's very important is that it's based on global standards for various reasons. And I think the biggest one is that if it's based on global standards, it provides you global economies of scale. It's something that you know will be deployed in many networks, and it also provides interoperability if needed. And you can kind of harness the power of that collective 3GPP standardization body to make sure that the technology is the best it can be. It has to be scalable as well. Again, different industry reports and forecasts are indicating that we'll have millions, if not billions, of objects connected to our network. So you have to have a technology that scales to meet those requirements. You have to also keep in mind that as that scalability increases or the need for those to serve those devices increases, you still have smartphones in your network that you have to serve as well. So you have to find a balance between these two different segments. And narrowband IoT has this beautiful feature in it that allows you to use the resources that are in the guard band of the carrier itself, meaning it's like on the shoulder of a highway. So you will not take resources away from your smartphones, but you can still serve those narrowband IoT customers without creating a conflict resource-wise between the two. So the scalability is another thing that's kind of an inherent part of narrowband IoT and 3GPP-based technologies. And then finally, being secure and based on licensed spectrum that allows us to have the predictability and consistent experience is very, very important. And 3GPP-based technologies or LTE and 5G-based technologies obviously have security as an inherent part of that. And these are the reasons why we believe the narrowband IoT and other IoT device categories that 3GPP has developed are the right technologies to serve the IoT segment that's about to explode in the near term. With that, I want to say thank you.
Thank you. Great Uncarrier story. All right, we're going to have Nakul come in and talk about his perspective of Qualcomm.
Thank you, Shai. Good afternoon. I'm Nakul Dugal. I manage the automotive product portfolio at Qualcomm. I'll give you a little bit of my perspective on IoT in the context of automotive. Different market, much larger players, a lot more concentration in terms of the opportunity, but a lot of change, a lot of transformation happening within the auto industry. So I'll hopefully try and give you some ideas to what we are seeing. So, this may not be broadly known, that we've been present in this space in the modem aspect of the technology for a number of years. We started back with GM in 2002. We acquired CSR back in 2015 and have a very good position on the Bluetooth side. And then we've been investing heavily in infotainment. What we are starting to see as far as the car goes, that it's becoming a platform that is going to have a variety of different use cases that are running concurrently. The car needs to get connected to the cloud because there are significant efficiencies that are possible within the auto industry in terms of how you actually get data off the car, how do you maintain the car, how do you diagnose it, how do you repair it. There are use cases that are driving consumer usage. I mean, my colleagues have talked about a number of use cases on the IoT side, but car sharing, rental services, just consumer applications. We are starting to see, I would say by the end of this decade, close to 70% attach in all developed markets for modems, and by 2024, 100% attach for modem connectivity in all cars. If you think about this in terms of the numbers, there are about 100 million or so cars produced globally, and typical automakers design cars over a 3 to 3.5 year design cycle. So you're talking about an addressable market of about 350 million vehicles that are available to address at every design opportunity. So that's the reason why this space is very interesting to us. We are fortunate in that we've had a very broad portfolio of technologies over the years that have allowed us to be able to address many opportunities in the automotive space by leveraging what we've been able to do in mobile, in connectivity, in wireless, in wired connectivity, power line communications. Really, if you think about the opportunities in terms of where the differentiation is starting to happen in the vehicle, there are maybe 2 or 3 main areas. One is what is known as the connected part of the vehicle, which is how do you connect the car internally, whether it's wired connectivity or wireless connectivity. How do you automate the car, or autonomous driving, which we can talk about a little bit. And then the entire sharing economy. The whole idea behind being able to make sure that you have a variety of these applications, these products available to allow for differentiation in terms of instrument cluster, in terms of infotainment, Wi-Fi within the vehicle, all the way moving over into level 2 autonomous driving, level 3 autonomous driving. All of this is being driven by fundamental technology differentiation that is starting to happen. To maybe switch over to connectivity a little bit, to my point earlier about the rate at which connectivity is expanding within the automotive ecosystem is really quite fascinating. If you think about the focus on autonomous driving, obviously very complex application, significant amount of new technology that is coming to bear across the industry. But in terms of the number of vehicles that will actually be on the road, even in the next 5 to 7 years, fairly small in terms of the number of cars that are produced. What we are starting to see is the complexity of connectivity inside the car is really exponentially increasing. So if you look on the left, that is what you might have seen as the connectivity hardware and software, some basic use cases as defined, say, for emergency calling, some monster type applications back in the 2003 to 2008 timeframe in the 2G, 3G world. As we start to look at moving over into 5G in Barcelona here, we've been talking to automakers and partners about timing for when we can bring 5G to the vehicle. Last week, time frames were in the 2021 window. We are now already talking about late 2020. So the complexity that you're seeing on the right-hand side is what a car is going to have to be able to deal with for its 5 to 7 year design cycle, and then that car remains in operation over a 10 to 15 year period. So significant opportunity for the entire value chain, but also a lot of planning, a lot of thinking ahead in terms of how the car gets designed, how antennas in the car get designed, how the engagement with the operator community gets set up. Here's an example of all of the various use cases. So there is a lot of debate around what will drive the need for 5G. What's the killer use case for? Why do you need so much capacity? I think, as Kari mentioned in his comments on unlimited data, being able to provide really data on tap, where you can actually design, if you assume that the network coverage affords it, you can design a platform that will essentially be able to compute very differently from the way that you compute today. So rather than having local storage, keep things on the cloud, get more real-time information. If you want to diagnose vehicles, you're diagnosing them real-time from the cloud. This is something that is, I would say, given the time frames that we're looking at, possible here in the next 3 years or so. So I think in the last 2 to 3 years, we have seen the intersection of AI, the intersection of high-performance compute, a lot of very sophisticated software, and now with 5G, high-speed connectivity that would allow the pricing for data to really be very affordable, which will create a paradigm shift in terms of how the car of the future gets designed. If you look on the right, one thing that's really interesting is that the car now actually has to engage with its environment in a couple of different scenarios. So there is the automaker that has to maintain a relationship with the vehicle over the life of the vehicle. There is the consumer that has a very different relationship with that same vehicle depending upon the environment within which the consumer is using the vehicle. And then there are safety applications that I'll talk about a bit more in detail. One thing that we have started to see consistently over the last couple of years is the need to be able to switch operators, not so much just for commercial purposes, but for the ability for the automaker to be able to have flexibility in terms of coverage, in terms of the quality of service available, commercial arrangements obviously, and that adds a new layer of complexity. eSIMs have been talked about for quite some time, but we are now starting to see a fairly sophisticated set of players emerge in terms of how the automaker engages with operators, but over the life of the vehicle, the ability to be able to move from one automaker to the other obviously adds a lot of complexity in terms of the hardware that goes into the vehicle. Another area of differentiation, I would say, in the automotive space, I think this is fairly common in the IoT space, is to be able to bundle airtime or bundle connectivity into the hardware. So if you look at the way that typical cars are sold today, you buy connectivity independent of the hardware. We're starting to see a big shift in China. We've been seeing this for quite some time. Hardware and connectivity get bundled together, and that allows for new business models to emerge. A lot of interest in high precision GPS, just to be able to get much better accuracy in terms of positioning for autonomous applications, in terms of a variety of asset tracking applications. And as you start to think about this in the context of safety, so one area that we've been focused on quite a bit, Andres talked about this a little bit in his presentation, is cellular V2X. We started focusing on this initiative in the last 18 months or so, and the thought was we wanted the wireless roadmap, 3GPP roadmap, starting off with LTE and moving over into 5G, as being the platform that allows for vehicles to be able to talk to other vehicles, vehicles to be able to talk to infrastructure. Now, if you think about this in the context of scale, this is one of those unique applications where globally it is harmonized already because there is ITS frequency spectrum available on a global basis. It's the same spectrum everywhere. So there is not a spectrum challenge. The application is the same because all automakers understand exactly what V2X means in their worlds. From a software stack perspective, SAE has been defining this for a number of years. For the infrastructure, the definition of infrastructure here is a little bit different. It is traffic infrastructure, roadway infrastructure. There is the need to be able to make transportation networks more intelligent, smarter, and connected. And that creates the opportunity for vehicles not to just talk to other vehicles, but also talk to infrastructure. One major area of focus, we are seeing this quite a bit in the US, in China, is in the context of a smart city. If you want to be able to have an intelligent traffic network, the ability to be able to sense what cars are seeing, upload that information up to the cloud, and have intelligent traffic management systems that are then able to provide real-time updates to vehicles that are on the road. So this is why we have had a lot of focus over the last year or so in this space. And we are basically going to enable much higher reliability, ability to be able to drive V2X at much higher speeds, obviously be forward compatible with 5G, so those investments are preserved. And we will integrate the technology into standard modems. So every time an automaker puts a modem in the car, that modem will have cellular V2X enabled already, and that's going to basically change the economics. We will reuse the entire development effort that was done by SAE and ETSI over the last couple of decades in terms of what was done on the SRC, so that there is no re-implementation of any of that effort. There are multiple discussions around where the traffic should be served from. So should the traffic between a car and infrastructure be served through the carrier network, or should it be served through an unlicensed PC5 link? I think every market is going to be slightly different. I think both options are available, obviously, in the technology. We believe that traffic that is more real-time in nature, that is more context-sensitive, context-related in terms of what's happening in the immediacy of the vehicle, has to be served real-time using a PC5 interface. Traffic that is more macro, things that have to be consolidated back in the cloud, can be served over the UU or the network interface. But really what this means in terms of all of you here who are representing telcos and that larger ecosystem is, this is new traffic, these are new applications. And if you start to think about 5G in the context of new use cases that the technology will define, this is something that is going to add a completely new dimension of use cases, of how vehicles engage with themselves, with infrastructure. So a lot of very interesting, cool opportunities that we envision in this space. Just to give you some perspective on 5G AA, so this is one of the few unique industry consortiums that are a confluence of the automotive industry and the telco industry. We formed this back in 2016, September, with 8 members. We had Audi, BMW, Daimler, Intel, HiSilicon, I think Ericsson and Vodafone. In 18 months, you can see the number of players that have been added to this consortium. So the amount of interest that we are seeing from the auto industry is just phenomenal in terms of how connectivity, wireless connectivity, will essentially change how we see cars out there in the future. And I think for all of us here, I think it's a fantastic opportunity in terms of what we can do with high-speed connectivity, low latency connectivity. I'll just leave you with the fact that the percentage of cars that are going to be connected, just as defined by automakers as we stand here in 2018, is about 75% of all cars globally connected by 2025. So huge opportunity in terms of the SAM. The use cases are fairly broad, all the way from safety to infotainment. We will see very broad LTE footprints. I think all of my colleagues would agree that LTE will be around for some time and will really become kind of the backbone for wireless networks with 5G being layered up on top. And I think there is going to be continuous innovation in terms of the number of different technologies, products, use cases that automotive will consume. Thank you.
Nice number of use cases around 5G. Rashmi from Microsoft will present her perspective on the ecosystem. Rashmi.
Good afternoon. So I'm going to talk to you about the perspective that we're seeing. I come from an organization that's Partner Devices Solutions. We work with thousands of partners to help realize their ambition and scale in this space in terms of really putting together a solution all the way from silicon to cloud. And our perspective on IoT is that really what we're seeing here is a business revolution in terms of enables something that's been enabled by technology, but actually has a feedback loop into business by enabling a system dynamic. Allows businesses to connect their products to customers, and it enables businesses to connect to assets that help them to do that. So if they're entering a journey for digital transformation, be it their ability to engage with their customers or empower their workers with productivity solutions, or being able to optimize their operations, or ultimately to even be able to transform their products. It's all a case of being able to connect the IoT solution, the information they get from it, to the actions that they can then create. And we see that in all sorts of spaces. So for example, in manufacturing, we're seeing that people are looking for machines that either do self-help, call for services, or actually never break down, or at least have a predictive view to it. In retail, ensuring that their customers have better experiences and really forging for new market opportunities. And in energy, to be able to provide a more efficient, cleaner use of power across their industry and their market. And of course in transportation, people, goods moving, to be able to provide consistency across the whole supply chain and be able to even track, use a more optimized view of energy, but also to be able to provide some sort of retaining view as you transport that product through the ecosystem. And then smart cities, a whole sort of ecosystem here in terms of how we create a more sustainable, economically viable environment to live in. And one of my favorites, in agriculture, really being able to track, from the field to the plate, or from the field to my handbag, dare I say. And healthcare, being able to really not just provide a view on what's going on, what might happen, but also to be able to really predict what may be happening in terms of symptoms, diagnosis, and therefore affect a better outcome for patients. So here's a simple view of IoT as we see it. Things connected in a system, providing a bunch of insights, but insights that are actionable for you. Insights that you can take actions from in terms of either being prescriptive, predictive, or being actually able to do some other insightful actions on your system. But here's the more realistic view that I think we're seeing, which is that actually it's not a case of just putting a whole system out there and saying, well, it will connect this. We're looking for things like end-to-end security. We're working in an environment that has legacy systems. We're looking at how we can integrate this into existing systems. Partners that are actually working across this whole chain, from the silicon to the drivers that they put on it, the operating system that we put on it, all the way to the commercialization of these devices, the deployment of them, integrating it into this whole system. There are a lot of players and a lot of challenges. And then, of course, we see this other evolution here as well, where there are cases where, with low latency, with privacy, and the need to do some data translation on premise or at the edge, but a need also to do more powerful things, maybe using a larger resource in the cloud. So an ability to split these workloads in a most optimal manner as well. And of course, I guess traditionally we're looking at things that really, those same sort of things that connect the insights and the actions we take, and then looking at an edge model where we really want to bring that to the edge, so that actually not only can I be maybe offline, not connected at a certain point, or at least have the option not to be connected, but be able to apply the same insights and the same actions closer to where my system might be deployed, but also to be able to leverage the heavy compute, the heavy resources back in a cloud perspective as well. So really connecting the intelligent cloud to the intelligent edge. So what we keep seeing is that IoT projects can be complex, and our partners keep telling us this as well. Difficult to maintain an end-to-end security perspective, especially when we're actually integrating into the legacy systems. Some of these devices, many of these devices, are really difficult to access today, really impractical to reboot if you're doing a security update, and generally poorly managed. And across the system, we see incompatibility not just with the existing structure, but also with processes as well. So, for example, the manufacturing of some of these devices is totally disparate from how they're actually installed and integrated as well. So being able to provision, to manage, and to really be able to manage across the lifespan of these individual components of the system is really important too. And then we work with partners in this ecosystem to actually understand, well, how does that scale process work? How does it actually, what does it mean to take this concept from silicon to solution to scale? And of course, the whole environment gets even more challenging, or let's say, provides us more opportunities, as depending on which analyst you look at, we're actually saying there's about 1 million devices that will go online an hour by 2020. And with increasing amounts of computing being done in the cloud today, we see another trend where the S&P 500, for example, used to have corporations that were much older than the 12 years that we reckon will be there by 2020. And that really says that, you know, the whole ecosystem in this space is really changing. There are newer partners, newer players in this space that will also be part of this system, and will still need to be able to secure these systems, ensure that they perform as we expect them to as well. And of course, this isn't a small industry. We're talking about numbers such as, if depending on which view you take here, of 1.3 trillion US dollars by 2020. And a lot of connected things in terms of 21 billion as one data point. And of course, if the value is all in the ecosystem, we're also seeing that it's split once again between the software, the hardware, the services, and of course the connectivity there as well. And those areas are also split across the different diverse types of players in this space as well. So today we work with ODMs, OEMs, the SIs that provide the solution and integrate the solution, ISVs that may provide applications on top of this, consultants that are actually bringing the business view from the very beginning of this project, and aggregators and distributors that actually go out and deploy these and monitor these systems on a day-to-day basis as well. So a large and growing ecosystem. So from our perspective, our ambition and our drive and what we strive for is really to simplify this space. And by that I mean to really simplify the process of building secure, scalable solutions from the device to the cloud. Making it easier to provision these devices even in that sort of disparate workflow environment. Easier to manage devices at scale, and I'm not just talking about updates of operating system and applications, but also being able to manage device and network configurations, device state properties that you would expect across the scale as well. And making it easier to find insights from your IoT device. Most people are not data scientists, are not AI experts out there, but they want to be able to reach easier insights, quicker insights on their data as well. At the end of the day, the whole point of really putting an IoT system out there is to have those insights so that you can take action into some system. And the investment, the return on investment is speeded up as soon as you get to that point where you can actually have some meaningful insights and actions from there. So being able to infuse devices with intelligence not just in terms of network and connectivity and cloud, but also right down to the devices and the monitors and sensors as well. Just making it generally easier to benefit from IoT. And today, we provide for that same reason that I said before, is that not everybody has the same sort of development resources, capabilities, skills, or desire to get down deep into certain things. So if you do want to, you've got the capability from the device support provided by Windows from us and Azure SDK capabilities. Then there's Azure IoT Edge, which actually allows you to have a gateway view that actually has the ability to connect or be disconnected as your workload requires. And then a whole capability in terms of IoT Hub for the connectivity of your devices, the provisioning of your devices from birth to its whole life cycle, and then a whole host of capabilities to access machine learning and AI capabilities at your level. You can either get in and build your models from scratch, train your models. You can access them via APIs or SDKs that you can drop into your own code, or actually just use the models that are there, created by partners in your own industry and shared to you as well. And a whole host of other BI and stream analytics capabilities as well. Now, if you just want to consume as a platform, there are some prepackaged configured solutions as well in terms of some of the verticals that you see there, connected factory smart spaces, and of course, ultimately, there is a SaaS type of model as a service to consume as well. So really connecting from device, gateway, and all the other players' perspective, that view that's happening in terms of the technical and the business transformation is what we see is essential to providing a comprehensive, secure, sustainable IoT solution in this space. And I want to thank you for that.
Nice job there, well done. I love the simplification message. Kiego-san from KDDI, all yours. Thank you. Very nice of you. Thank you.
Good afternoon, everyone. My name is Keigo Harada from KDDI. I'd like to thank you for giving me the opportunity to speak today. Today, I'd like to talk about delivering Iot EcoSystem. Let's go on to the next slide. This timeline shows KDDI's M2M IoT history since 2001. IoT split rapidly about 2 or 3 years ago, about here. But we started the same type of business, M2M, which means machine to machine, almost 15 years ago, from 2001. In 2001, we launched the Kogosecom system with Seiko, which is the largest security company in Japan. In 2002, we launched the G-Book with Toyota Motors. In 2007, we launched the service management system with Isuzu Motors. This system encourages eco-friendly and safety driving. In 2015, over there, we launched the smart meter with electric companies in Japan. 9 out of 10 electric companies adopted our circuit in Japan. In 2016, we released the global communication platform with Toyota Motors. On the bottom side, you can see that this timeline shows the KDDI IoT service development history. Thanks to the customer, we developed many types of service, IoT service. Please go on to the next slide. This chart shows that the number of the M2M IoT circuit for enterprise customers has been growing steadily from 2001, steadily. Especially since 2015, the number of IoT circuits has been growing exponentially, you can see. These circuits include IoT smart meter and IoT connection for POC, proof of concept, in various industries. That's why growing exponentially. Let's go on to the next slide. So last January, we launched the first LPWA service in Japan. We adopted the LTE method at first. Also, we will also launch the LB IoT service in March, next month. We are the most active carrier in LPWA, of LPWA in Japan. So, this slide, you can see the overall picture of KDDI IoT solutions. There are 3 layers. In the middle, you can see the cloud and you can see the network layer. We provide the LTE, this one, and we provide a global communication platform, not only for Toyota, but also for various industries. We also offer the KDDI IoT Connect Air, powered by Soracom. So we also provide both unlicensed LPWA and the cellular LPWA. We support both types of methods. On the top side, you can see the cloud layers. We provide the KDDI cloud standard, left one. We support over 2,000 sensors. We provide this one. And provide visualization. It's a really popular service in KDDI. So we also provide KDDI IoT Cloud Creator in top middle side. We support the agile development method. On the top right side, you can see we support the KDDI IoT Cloud Data Market and the KDDI IoT Cloud API Market. I'll talk about it later. On the bottom, this is the device layer. We support over 2,000 sensors, I said last time, and brand module, KDDI brand module, and SIM security. So we provide all layers at once, and support corporate customers. Please go on to the next slide. Today, I will focus on a really unique service, the IoT cloud data market. You can see. Recently, we have been facing a new need from customers. For example, our customer said, how to utilize accumulated data? How to find a business opportunities by combining data? How will handle data analytics? So KDDI facilitates buying and selling data, and KDDI offers the advanced analytics. Please go on to the next page. So this picture shows the KDIT cloud data market. This is a really new service. First, we prepare data which we think is suitable for customers in advance. For example, shop information, the left side. This is to know about the customer's competitor shop information. And second one is the point of sales information. And third one is the demographic forecast. And so on in the KDIT data market. So there are over 10 types of data and over 6 types of API in the KDIT cloud API market. So if customer generate the data, number 2, then we combine our customer's data with the prepared data in the IoT cloud data market. Then we analyze the data together. Number 3, analytics service. And find a new value. Number 4, for our customers. This is the example. On the right side, you can see the vehicle data on the map. Red line shows the vehicle traffic. So you can easily check the traffic volume and speed using this map. So if you can open a new store, you can easily find a good location to open it. For example, heavy traffic roads are suitable spots for opening new stores. It's a really convenient data. In conclusion, this pair shows the IoT ecosystem we think. So first one, we prepare data with the data partners. So if customer generates the data, number 2, we combine our data, combine the IoT data with the prepared data. Then we analyze data together and find the new value to a customer. Left side is the customer, original customer. On the right side is the important thing, the other customers. So we find the value to the original customer and the other customer. It's a really important point. So if customer pay for new value, we share this revenue with data partners. So customer pay some money, so we share the revenue with data partners. So we call it the revenue share ecosystem using IoT data. This is a really usual revenue share pattern. Actually, KDJ has been studying this type of new business with enterprise customers, this one, and with many data partners. So this is the end of my presentation. If you have any question, please let me know after this session. Thank you for your attention.
Kira-san, thank you so much. Thank you. Well, this is all the time we have. Hopefully you were able to take some good takeaways from this one. As you can see, this market is increasingly becoming very complex and sophisticated. And with that, thank you very much for your time, and see you on the trail.